Okay, Bismillahirrahmanirrahim. Today we are going to perform experiment number 6. Actually, there are two parts of this experiment. The first one is verification of Thevenin's theorem, and the second part is verification of maximum power transfer theorem. As you have just started it in your theory class, so I am going to give a short overview of the theory first, and then we will perform the lab. Okay, so let us first discuss about Thevenin's theorem. What does it imply? What does it say? Thevenin theorem is applicable.
आपका मैसेज হচ্ছে টিঙ্কার কার্ডের ক্লাস আইডি টাইপ
ক্লাস আইডি ওকে, ঠিক আছে। আচ্ছা, আমি একটু থিওরিটা পড়াই নাই, তারপরে ক্লাস আইডি দিয়ে দিচ্ছি। বা ক্লাস আইডি মনে হয় আপনাদের দেয়া আছে না ক্লাসরুমে? আচ্ছা, আমি পরে দিয়ে দিব, টিঙ্কার কার্ডে শুরু হওয়ার আগে তখন দিয়ে দিব। Okay, so Thevenin theorem is applicable for a linear and two-terminal network. Bilateral also means two-terminal. So what is linear network and what is non-linear network? Can anyone give an example of a linear element of circuit and a non-linear element? Do you know what is linear element and what is non-linear element? Any idea? Okay, let me give you a simple example. We know the voltage and current relationship of a resistor, right? What is the relationship? V equals to IR. So if we plot this relationship, the voltage versus current relationship across a resistor, then what should the graph look like?
So a straight line.
Exactly, the graph should be a straight line like this. So this is called linear element because the voltage and current in a resistor follows a straight line or a linear relationship. Okay, on the other hand, maybe some of you have heard about a diode, right? This is the symbol of diode. In another course, probably in CSE251, you will learn the voltage current characteristics of a diode. The voltage current relationship in a diode looks like this. So please tell me, does it look like a straight line? Of course, no. So diode is a non-linear element. Now, as we are talking about Thevenin's theorem is only applicable for a particular circuit where there is no nonlinear element, which means all the elements must be linear. There are two other examples of linear element. We just discussed about resistor. The other two elements are inductor and capacitor. These two elements are also linear. Okay, and in this course we have learned about some sources, right? Dependent source, independent source, voltage source, current source, etc. All these sources are also linear element. So in this type of linear circuit which contains some source and some resistor or maybe inductor capacitor, we can apply Thevenin's theorem on that circuit. Is it clear? Now, what does the theorem wants to say? It is actually somehow similar to our equivalent resistor concept. We all know about series parallel equivalent resistance, right? For example, say this is a circuit containing 3 resistors. We know that using the series parallel relationship, we can replace this whole circuit using just one resistor, which we call equivalent resistance, right? We all can calculate the equivalent resistance, right? In a similar manner, the Thevenin's theorem helps us to replace a particular portion of a circuit with an equivalent circuit. What I am trying to say, let's observe this example here, or I have already drawn it for you. Just a second. Let's observe this circuit here. Just look at this circuit. Can you say any nonlinear element?
No, sir.
There are 4 resistors and 1 source. All of these are linear elements. So what we can do is we can replace a particular portion of this circuit using an equivalent circuit. Just for example, I want to replace this portion. There are 3 resistors and 1 source within this boxed area. And what I can do using Thevenin's theorem, I can replace this part by using only 2 elements, 1 voltage source and 1 resistor in series connection with the source. Do you understand? Using Thevenin theorem, we can replace a complex circuit or a large circuit just by 2 elements. The 2 elements are, one is voltage source and another is a resistor connected in series with the source. Is it clear?
Yes, sir.
Now, as you have learned something about it in theory class, can someone explain that why do we need this theorem, or what is the practical application? What is the significance of this theorem? Any idea? Anyone? You can tell in Bangla, no problem. Okay, let me give you some idea. In real life, what actually happens is we want to drive, or we want to operate an electrical component using a particular circuit. That component or that electrical equipment is known as load resistor, or simply load. You can imagine that the electrical equipment in your house, say the fans, the lights, the electric motors, all these are loads. Now think that for different time, say in the morning and in the evening, do we use same amount of load? Do we operate same amount of light, fans in all the same time, in all the time of a day?
No, sir.
Obviously not. So we can treat the load as a variable resistor, a variable element of the circuit. Apart from this load, all other parts of this circuit are actually constant, which means they do not change with time, right? So say I ask you to measure the voltage and current across this load resistor for this particular values. Okay. Now, when the load resistor will change, you have to calculate those values again, right? This load resistor shown here is showing 1 kilo ohm. Now, when it will be 2 kilo ohm or 1.5 kilo ohm, you have to analyze this circuit from beginning to end once again, right? And if this circuit gets larger, the calculation will also be more complex, right? But as we know that only this portion of the circuit is variable and the rest is fixed, so what we can do is replace this large part using the equivalent Thevenin circuit. I think it is clear that instead of analyzing this large circuit, it is much easier to analyze this small circuit. Is it clear to everyone?
Yes, sir. Yes, sir.
So every time the load changes, we can just simply use KVL or KCL and find out the load voltage and load current from the equivalent circuit instead of looking at the original circuit. Everyone got my point?
Yes.
Okay. So that's it. Now, let's talk about the works of our lab today. First, we will try to verify Thevenin's theorem, not just use Thevenin's theorem. So how can we verify the theorem? Just as I mentioned earlier, that this large portion of circuit is equivalent to this one. So how can we verify this equivalency? Can anyone tell me? I am telling, or I am claiming that this circuit and this circuit are equal. So how can we verify it?
তুলোর দুটো সমান নাকি আর ভোল্টেজের
একটু জোরে বলেন তো, মনে হয় ঠিক বলছেন, আরেকবার বলেন।
তুল্য রোধ মানে সমান আর ওটার রোধটা সমান নাকি ওটা?
তুল্য রোধ না, দেখেন এখানে যে রোধ ছাড়া আরো এলিমেন্ট আছে, যে সোর্স আছে,
ভোল্টেজের
আমরা তো সোর্সকেও রিপ্লেস করে ফেলতেছি, পুরো একটা সার্কিটের পোরশনকে রিপ্লেস করে ফেলতেছি। হ্যাঁ বলেন
স্যার, লাস্ট দিকে যে দুটো পয়েন্ট আছে, ওইটার হচ্ছে ভোল্টেজটা আর এই ইকুইভ্যালেন্ট সার্কিটের ভোল্টেজটা সেম কিনা ওটা দেখে।
Exactly, thank you. What we have done here, we have replaced these 2 points with these 2 points, right? So we have to measure that this voltage, or we can denote it by load voltage VL. This voltage and this current, the load current IL, should be equal with this equivalent circuit. This one is VL and the current flowing here is IL. So what we will do in Tinkercad, first we will build this large circuit and measure VL and IL for some values of load resistor. Say we will take load resistor 1K and 2K, and we will measure what are the values of voltage and current. Then we will draw another circuit, this one, and again measure the voltage and currents. So we will just check whether these values are same or not. If the values are same, then we can claim that yes, we have verified Thevenin's theorem. Got it, everyone?
Yes.
So our first task is to build the original circuit, the left one, and measure voltage and current across load resistor. So I think we can start now with Tinkercad. Everyone, please go to Tinkercad. Okay, I am sharing the class code. Someone asked for it. I am not out. Okay, this is section 2. I am copy pasting the class code in chat box. If someone has not joined already, please join.
স্যার আমরা ইউজার নেম কি দিয়েছিলাম আমাদের সবারটা?
ইউজার নেম নাকি নিকনেম, কোনটার কথা বলতেছেন?
নিকনেম, সরি স্যার।
হ্যাঁ, নিকনেম নাই, নিকনেম লাগবে না। আপনি হচ্ছে আপনার ইমেইল আইডি দিয়ে লগ ইন করবেন, নিকনেম না।
ওকে স্যার।
Okay. So I'm creating a class activity. Everyone, please log in into your Tinkercad account and try to find this class activity. First, go inside this class activity and then create a circuit. From create new design, you should click on the circuit option. Please make sure that you are creating the circuit within this class activity. Is it clear?
স্যার কোথায় গিয়ে পাবো আরেকবার দেখ?
আচ্ছা, আমারটার সাথে এখানে না ঠিক পুরোপুরি মিলবে না, মানে আপনি আপনার টিঙ্কারক্যাড অ্যাকাউন্টে ঢুকলেই মেবি দেখতে পাওয়ার কথা। দাঁড়ান, তাও একটু দেখাই। এরকম কোন একটা অ্যাক্টিভিটি ট্যাব কি দেখা যায় আপনার এখানে? অ্যাক্টিভিটি,
স্যার ইউর ক্লাসে ঢুকলেই আসবে।
ইওর টাস্ক, হ্যাঁ আচ্ছা রাইট, আপনার ওখানে টাস্ক
New
হিসেবে
task
যাবে
আছে।
জিনিসটা। হ্যাঁ, ওই টাস্কে ঢুকে তারপরে একটা ক্রিয়েট নিউ সার্কিট করেন। ওকে, so everyone, did you find the activity? Now, first of all, please rename the circuit in this manner: experiment 6 part 1 underscore your student ID. exp6 part
স্যার
1
আমরা অ্যাকচুয়ালি
student
পাচ্ছি
ID.
না ইওর টাস্কটাও খুঁজে।
কি
ইউর
পাচ্ছেন না?
ইউর ক্লাসে যাবো, ইউর ক্লাস সিএল এ যাবো।
ক্লাসে যান, দেখেন CSE250-02L, তারপরে ক্লাস অ্যাক্টিভিটি, এরকম কিছু থাকার কথা।
ওকে স্যার, গড।
Okay, everyone, please be attentive now. We have to build this circuit in Tinkercad. So we have shown many samples of circuit before your mid exam. I hope this one wouldn't be difficult for you. So I am just doing it a bit quickly. Please try to follow me and also complete your own circuit. First, we need a breadboard and a power supply. I'm connecting the power supply with the positive and negative line. Okay. Next, observe that we need total 4 register, right? So just to be sure that we won't make a mess of R1, R2, R3, I am going to call this R1, this one R2, and this one R3. Okay, everybody clear? R1, R2, and then R3. Let me place these resistors. R1, R2, R3, and then we need another load resistor RL at this node. So all the registers are placed. Now we need to connect them with the power supply, right? So what I'm going to do is connect this part with the positive terminal using a green wire, and with negative terminal we have to connect all these three terminal, all the three registers, right? So what we can do is first we can short these two terminal, and then we can short this one, and then we can connect it to the negative terminal. Okay. I didn't explain it too much. I hope everyone has got the idea how to build this circuit. If anyone have any confusion, you can tell me. Is the connection clear to everyone? Okay, next we have to set the register values and the power supply values, right? Okay. So there are some values mentioned in the lab sheet, but we are not going to follow this. We will change the register values according to your student ID. How we will set the values? Just let me give this example. I think you are all familiar with this type of register value settings. Just leave out the first two digits of your student ID. Your R1 would be 1 point, this 2 digit. R2 would be 1 point, the next 2 digit, and R3 would be 1 point, the last 2 digit. Okay, is it clear, everyone?
Yes, sir.
So please set the register values according to your student ID. I am going to set it according to my dummy ID 1.34. You can also rename the register just for your better understanding. This one is R1, this one R2, and this one is R3. So I have not said anything for RL yet. I'm just going to rename it RL, and we will put its value later. So please set the values of R1, R2, and R3. Leave the RL for now. We will come back to it. Next, the source value. Everyone can keep it the same one, the 10 volt. Okay. Please set the source voltage to 10 volt, and the current should be just as it is. 5 ampere is good enough. Okay. Now time for the data sheet. Everyone, please go to our Discord announcement channel and find the datasheet link, experiment 6 datasheet. Okay, everyone, please open the datasheet. Now it is in view only mode, so you need to create your own copy. Go to file and make a copy option. Please rename the datasheet in this manner: experiment 6 underscore your student ID, exp6 underscore your student ID. Okay. Has everyone made a copy? Now, first of all, please fill up this small table. We have just set these values in Tinkercad. So according to that, please fill up this table. For everyone, Vs is 10 volt, R1, R2, R3. These three are different for every student. So please fill up according to your values. Everyone done? Can I proceed?
Yes, sir.
Now what we will do, we will take 3 observations. For each observation, we will set RL or the load register to a different value. Now we can actually take any value, whatever we want, just from 1 ohm to 1 kilo ohm or 1 mega ohm, anything. Now, just for simplicity, it's better if you all follow the same convention. Say the first RL will be 100 ohm, or as we are writing it in kilo ohm, it will be 0.1. For second observation, we will use 1 kilo ohm, and for the third one, we can use say 2 kilo ohm. Okay. Anyone can use any value, whatever you want. I have just given an example: 100 ohm, 1 kilo ohm, and 2 kilo ohm. For each observation, what we will measure? The load voltage VL and the load current IL. Okay. So let's go to Tinkercad again and set load register to our first observation. In first observation, I put 0.1 kilo ohm or 100 ohm. Okay. Now we need to measure the load voltage, right? So what we will need to measure the voltage?
Multimeter.
Right. We need a multimeter in voltmeter mode. And as we know that voltmeter is connected in parallel with a resistor. So we have to complete this connection now. Let's do it. Search for the multimeter. Place it here. And then we need to connect the multimeter across the load register. Okay. So for the positive connection, what I am going to do is, let's say I connect it here, the positive terminal or the first terminal of load register, and the negative is actually the negative terminal of source. So I just connected it with the negative end of power supply or source. Is this connection clear to everyone?
Yes, sir.
Okay. So time for measurement. Please simulate the circuit, and you should be able to see a voltage reading in your multimeter. For my case, the voltage is showing in millivolt. So nothing to worry, but please make sure that you write this voltage in volt unit in your data sheet. For my case, it is 572 millivolt. So I am going to write 0.572 volt. Is it clear? Everyone?
Yes, sir.
So that is our load voltage for 100 ohm load. Now, how can we measure the sorry, ভোল্টেজটা 0 আসছে?
জি স্যার।
আচ্ছা, এই কারেন্টটা কত দেখাচ্ছে? সোর্সের কারেন্টও 0 দেখাচ্ছে?
জি স্যার।
তার মানে আপনার কোনো কানেকশনই হয় নাই, কিছুই হয় নাই। কানেকশনটা একটু দেখে দেখে ঠিক করেন, এটা তো এতদিনে পারা উচিত। খুবই সিম্পল কানেকশন। একটু
ওকে
দেখেন
স্যার,
এই
ট্রাই
যে
করছি।
কলাম রো গুলো ইন্টারচেঞ্জ করে ফেলছেন হয়তো। Okay, now we need to measure the load current. We can use an ammeter or we can use some alternative, right? What is the alternative of ammeter? How can we measure the load current without using an ammeter?
মাল্টিমিটার ইউজ করে ভোল্টেজ বের করে করতে পারেন।
Exactly, we have already measured the voltage. So what we can do, we can divide this voltage by the load resistor value. That will give us the load current IL. Simple. So we do not need to take another measurement from Tinkercad. We already have the values of VAL and RL ready over here. So we can use a simple function. The function would be VAL divided by RL. That's it. The current is automatically calculated in milliampere unit. Why? Because we have put the resistor values in kilo ohm. So when something is divided by kilo or 10 to the power 3, it becomes 10 to the power minus 3 or milli. Is it clear to everyone? Okay, so that is observation number 1. I have done it for you. Now, please.
Sir, can you repeat the last part?
The IL measurement.
Yes, sir.
Okay. We can use an ammeter, but instead of an ammeter, what we can do is we can use the Ohm's law. I equals to V by R, right? So we have already measured the voltage VL and we know the RL. So we can divide this by this one. So I am just using Excel function here by putting an equal sign, then clicking on this cell, divide by this cell. So this gives us the value of current in milliampere unit, not in ampere unit. Anything else?
No, sir. Thank you.
So everyone, please complete the observation number 2 and 3. What you need to do is simply change the load resistor value, observe the voltage from multimeter, and then calculate the current using Ohm's law. I hope this won't take more than 2 or 3 minutes. So everyone, please complete it. In the meantime, if anyone has any question or any difficulty, you can tell us. Okay, is everyone done with observation number 2 and 3? Can I proceed to next step? Okay. So our next task is to build this equivalent circuit. this simple one over here. We will build this circuit and then we will verify whether the voltage and current values remain the same or not. Okay. Now, okay. To build this circuit, we need to know the voltage source value and this resistor value, right? Let me first denote it with V Thevenin or VTH and R Thevenin, RTH. How can we measure these two values? Probably you have already learned it in your theory class or maybe going to learn it very soon. I will also discuss it now and then we will measure these two values. Okay, first VThevenin. Measuring VThevenin or calculating VThevenin in theory can be a little difficult, but in practical or in laboratory, measuring VThevenin is pretty easy. What we need to do is we need to remove the load resistor, or we need to create an open circuit at the load resistor terminal. Please observe and compare it with the previous circuit. Our load resistor was connected here, right? So what we have done here, we have just removed or created an open circuit in these two terminals. Next, we need to measure this open circuit voltage denoted by VOC. How can we measure this open circuit voltage? Simply by using a voltmeter, right? The open circuit voltage is called VThevenin. That's it. So it's pretty easy, I think. Everyone understood? We need to remove the load resistor and then measure the open circuit voltage. In theory, how we do it? We need to apply nodal analysis, mesh analysis, superposition, something, and then we need to calculate this open circuit voltage. So that process is a little bit daunting, but here it is very simple. Okay. And then we need to calculate the resistance, R Thevenin. Okay, so there are maybe 2 or 3 methods to measure R Thevenin. For today's lab, we will use the most simple one. Okay, how we can measure R Thevenin? Look at this circuit here. Just a little bit ago, what we did, we opened the circuit here, right? And now what we are going to do is we are going to create a short circuit between the load resistor terminal. Look here, it was an open circuit and now we just created a short circuit. After creating this short circuit, we need to measure this short circuit current, ISC. We can use an ammeter to measure this current. And then we can use Ohm's law to measure the R Thevenin. R Thevenin is equals to the open circuit voltage, or which is same as V Thevenin, divided by short circuit current. So this is the formula we are going to use today for R Thevenin. Is it clear to everybody how we can measure V Thevenin and R Thevenin?
Yes, sir.
Okay, so let's do it in Tinkercad. First, let's measure the V Thevenin. To measure V Thevenin, we just need to disconnect or open circuit this load, right? So just click on this load resistor and delete it. Just click on the load resistor and delete it. So if we delete the resistor, we have actually created an open circuit. And please remember that this voltmeter is already connected as we want it, right? So we do not need to give any more connection or change anything. Just simulate this circuit, and this value is your open circuit voltage or VThevenin. Okay, everyone, please respond. What is your VThevenin voltage? I hope it should be around 4 volt to 6-7 volt.
It's actually
5.60.
5 point.
5.2.
Okay, next, someone else. Is there anyone whose VThevenin is like below 2 volt or below 1 volt? Anyone? Or anyone whose VThevenin is greater than 10 volt, something like that? No. Okay. So I think everyone has. Yes, please.
স্যার আচ্ছা এখানে যদি আমি রেজিস্ট্যান্সটা মানে না
আচ্ছা, আপনার কথা খুব আস্তে শুনতে পাচ্ছি, একটু জোরে।
স্যার এখানে যদি শোনা যাচ্ছে?
শুনতে পাচ্ছি।
এখানে যদি আমি রেজিস্টারটা রিমুভ না করে 0 ওহম দিয়ে দিতাম তাহলে কি কাজটা করতে?
রিমুভ না করে যদি কি করেন?
0 ওহম।
না, 0 ওহম মানে হচ্ছে শর্ট সার্কিট, সেটা তো হবেই না। আর টিঙ্কার ক্যাডে আসলে 0 ওহমকে ঠিক কিভাবে ট্রিট করে এটা আমি শিওর না, বাট এমনিতে থিওরিটিক্যালি যদি চিন্তা করেন যে খুব লো একটা রেজিস্ট্যান্স, সেটা হচ্ছে শর্ট সার্কিটের কাছাকাছি। আপনি যেটা করতে পারেন, আপনার আইডিয়াটা যদি ইমপ্লিমেন্ট করতে চান, তাহলে যেটা করতে হবে, অনেক হাই একটা রেজিস্ট্যান্স দিতে হবে, লাইক গিগা ওহম। বুঝতে পারছি? মেগা ওহম তার চেয়েও বড় হচ্ছে গিগা ওহম। এরকম একটা কিছু যদি দেন, তাহলে সেটা অলমোস্ট ক্লোজ টু ওপেন সার্কিট হয়ে যাবে। ওকে, ঠিক আছে। So everyone, if you are done with measuring this value, please put it in your data sheet here, VThevenin. For my example, it is 5.33 volt. Please observe what is your value and write it accordingly. Okay, everyone done? Next, we need to measure the Thevenin. So what was the theory? To measure Thevenin, we actually need to measure the short circuit current. That means we need to connect these two terminals using a wire or short these two nodes, right? Then we need to measure the current. Okay. So in previous experiments, we always tried to avoid the ammeter, right? We always used voltmeter and then use the Ohm's law to calculate current, I equals to V by R. Now for this particular case, I think we can use ammeter because in none of the experiments you have used an ammeter. So it is necessary to understand how to connect an ammeter or how to take reading from an ammeter. So just for this particular task, for this single task, today we are going to use an ammeter. Okay, first tell me, how do we connect an ammeter in circuit?
Series, sir. Series.
In series, right?
In a series.
Okay, so if we want to measure this current, we need to connect an ammeter in this series path, right here, right? So interestingly, please observe that the connection of voltmeter that is already connected in our Tinkercad circuit, isn't it similar with the ammeter connection? Look at the red and green wires. Isn't it the same? So actually,
Yes, sir.
we
They
do not
are
need to connect any short circuit or any extra wire like this one. We do not need it. What we need to do is just simply change this voltmeter to ammeter mode. That's it. This is the series connection. Is it clear? So it is going to be very easy for us to do in Tinkercad because we have already connected this multimeter just in voltmeter mode, and now we are going to change the mode to ammeter. Okay, everyone, please click on your multimeter and see there is
Sir,
a voltage. Yes, please.
don't we need to remove those two connections? How do I?
Which two connections? This
If
one
we
and
if
this one.
no, if we go back to Tinkercad,
Okay.
so from negative rail to J17.
Negative rail to J17. Where is J17? Okay, this one.
This one, and like from B13 to J17. Don't we need to remove this one? These two connections?
Just a minute. Why did we connect this one? Let me see. These two. No, we do not need to remove that because please observe that these two resistors, the vertical two, they are connected with the negative terminal, right? Connected
Yes,
with
sir.
the negative terminal of the source. So that purpose is served by these two lines. This one, and then this line goes to
Oh,
the
and
negative terminal. Okay.
yes, sir. Yes, yes.
Okay. So all right, everyone, please change your multimeter mode from voltage to amperage. Now this multimeter would act like an ammeter. So that's it. Simple. Start the simulation and you should be able to observe the short circuit current, hopefully in milliampere, 6.41 milliampere. Okay, so everyone, can you see the current reading? It shouldn't be 0 or it shouldn't be something like error, but it should be some milliampere. Okay. Now we can use this formula to calculate RThevenin. RThevenin equals to VThevenin divided by ISC. Okay. So I'm just going to write this formula directly in here in this cell. Everyone, please follow me and go to your data sheet and fill up the RThevenin cell. Okay. So what is my RThevenin? VThevenin divided by the current. What was my current? 6.41 milliampere. You should put the current in milliampere unit so that the resistance is calculated in kilo ohms. Okay. You do not need to convert the milliampere into ampere. Just don't do that. Just put it in milliampere and we will get our RThevenin in kilo ohm. Okay. Everyone done? So that's it with our first circuit. Now we are ready to move on to the equivalent circuit, this one. So everyone, please create another Tinkercad circuit and make sure this one is also within your class task or activities. Everyone, create another circuit within your class activity. Okay, first rename it EXP6 part 2 and then your 8-digit student ID. EXP6 part 2, your 8-digit student ID. Okay, everyone, done. So let's build this circuit, the Thevenin equivalent circuit over here. And as you can see, it can't get any more simpler, right? It is very simple circuit, just 2 resistors connected in series with this power supply. So I am going to connect it. Please follow me, or I hope you can do it on your own. Power supply. Okay, the connection is done. If anyone has got any confusion, you can ask me. Okay, now please answer. What will be the value of power supply? 5 volt, 10 volt, or what? Someone please tell me.
Sir, Thevenin.
It won't be the same for everyone. It will be the Thevenin value that you just found from your previous circuit. So in my case, the Thevenin was 5.33 volt. I am going to write it here. Please observe what was your Thevenin and set the power supply accordingly. Next, the first resistor, we can rename it Thevenin. Okay. So this value is also going to be different for each of you. In my case, it was 0.8315 kilo ohms. So I'm going to write it here, 0.8315 kilo ohms. Okay. Now, what will be the value of load resistor? You can rename it RL. And please tell me what will be this value.
Sir, the 3 values from the beginning.
Exactly. As we want to verify the Thevenin's theorem, so we need to use the same 3 values that we used in the original circuit. So let me complete the first observation for you. For first observation, my RL was 100 ohms or 0.1 kilo ohm. So I am going to set it right here, 0.1 kilo ohm. Okay. So in a similar manner, we can measure the VL and IL, right? We need to connect a voltmeter in parallel with the load resistor. So let's do it. Follow me and connect your own circuit. This is the multimeter. the positive terminal, and this one is the negative. Okay. So if we were done with the connection, please start the simulation and you should be able to see the voltage reading VL. In my case, it is 572 millivolt, which is same as my previous table, and it should be same.
কারেন্ট কত দিব?
Oh, current maximum যেটা আছে ওটা থাকে 5 অ্যাম্পিয়ার থাকে না, ওটাই থাকে।
আর লোড ভোল্টেজে হচ্ছে ফার্স্ট যে R1 টা মেইন সার্কিটে নিছিলাম ওইটা।
These three values you should just copy it here. Okay. Please notice whether your VL is same or not. It should be same because we are doing it in simulation, and the only error we can face is like the precision lost. Maybe the previous one was 5.7 572 and this one can be 571. That's it. Okay. Again, we do not need to measure IL.
পয়েন্টের পরে একটু চেঞ্জ আসছে।
সামান্য চেঞ্জ আসতে পারে, সমস্যা নেই। To measure IL, we can use Ohm's law, VL by RL. So everyone, please complete the observation number 2 and 3. I'm giving you some time. Please complete these two observations. Okay, is everyone done? Can sorry. Has anyone found any discrepancy between these two tables? Okay, I hope everyone is good. Now we can move on to our part 2. Okay, the objective of this part is to verify the maximum power transfer theorem. This theorem is closely related to Thevenin's theorem. That is why we are going to complete this task along with the Thevenin. Okay. Now, what does this theorem imply? To verify this theorem, we do not need to create another circuit. We will just use this circuit, what we have just built in Tinkercad. The maximum power transfer theorem states something related to the power consumption of this load resistor. First, imagine this. As we learned today that the load resistor, or simply the load RL, this is some electrical machine that we want to drive or we want to operate using this circuit, right? So in general, what would we expect? Do we expect the load resistor to consume most of the power, or do we expect the Thevenin resistor to consume most of the power?
So load resistor.
Obviously the load, because any power that is consumed somewhere other than the load, it is eventually some sort of waste, right? We do not get any mechanical work from that power. Only the power absorbed in load is actually converted into work or some sort of other energy, right? So we want that the load resistor absorb or the load resistor dissipate maximum amount of power. In order to achieve that, there is a relationship of R Thevenin and RL. So have you covered it in your theory class? Do you know the relationship or the condition where maximum power will be transferred to load? Okay. If it is not covered, then let's do an interesting thing that I am not just going to tell you the condition. We are going to take some data and then create a graph. The graph should be like this. For different values of RL, we are going to plot the output power or the power absorbed by RL. And then we will find for which particular value of RL the power becomes maximum. I'm just giving you a hint that the power graph will look like this. So we can see from the graph that for this particular value of RL, the power is maximum, right? Is it clear?
Yes.
So we want to check what is this value. Okay. It is already stated in maximum power transfer theorem, but as it is not covered in your theory class and we have an opportunity to find out the value, so let's do it in this way. Okay, so first let me show you the data table for this task. This is the data table. Yes, it looks large, but it is not going to be very difficult to fill up because we need to measure just one value, the load voltage. Apart from this one, all the other columns will be calculated using some formula. The formulas are already written in your Excel sheet. Okay. So what we are going to do is vary the load resistor, and for each RL value, we are going to measure the load voltage and then calculate the other quantities using formula. Is it clear?
Yes, sir.
Okay. Now, what should be the values of RL? You can take any value, yes, of course, but I am giving you an idea what you should do. You should take RL in in such a range that the Thevenin lies somewhere within this range. For example, in my case, the Thevenin was 0.83 kilo ohms, right? 0.83 kilo. So what I can do is I can take some load resistor values which are less than Thevenin. Say I'm going to take 0.1 kilo, 0.3 kilo. All these are in kilo ohms, right? 0.1 kilo, 0.3 kilo, say 0.5 kilo. That's it. And then I am going to take the Thevenin value as RL, 0.83 kilo. And then some values which are larger than RL, say 1 kilo, 2 kilo, say 2.5 kilo. Okay. So these values do not need to be exactly the way I have written here. According to your Thevenin, you can choose your own range. Okay. Now, no need to worry right now. We are going to see.
স্যার আমার রেঞ্জ তো 5 পর্যন্ত,
Sorry,
0.5 আসছে আমার
R7 কত আসছে?
আর 0.55।
0.55, সমস্যা নেই, ঠিক আছে, আপনিও মোটামুটি এরকমই নিতে পারেন। আচ্ছা, আমি দেখাচ্ছি এখনো কিভাবে নিতে হবে, আরো কিছু কথা আছে, শোনেন একটু। Okay, so for each observation we need to change this load register, right? In Tinkercad it is pretty easy to do. We can just click here and we can just rewrite the value, right? However, in real life, changing a register value is not easy like this. What we have in our laboratory is we have a potentiometer. Potentiometer, what is it? It is actually a variable register. In a potentiometer, there is a knob which we can move just like the regulator of a fan, and we can adjust the register value. So for today's task, we are going to use that potentiometer instead of just clicking and changing the register value here. Okay, is it clear? So we can delete this load register. We are not going to use this one. Instead, we are going to use a variable register known as potentiometer. Everyone, please search for potentiometer and you should be able to see something like this, a round element. Has everyone found potentiometer?
Yes, sir.
Now, how does this component work? As you can see, there are 3 terminals, right? For a simple register, we know that there are only 2 terminals and even there is no polarity. I mean, there is no plus minus for register. So what does these 3 terminals do in a potentiometer? Let's understand it first. Okay, you can think the potentiometer like a long register like this. Okay, so this is the left terminal and this is the right terminal. According to our Tinkercad notation, this is terminal 1 and this is terminal 2. So let me write it in this way. This is T1 and this is T2. Now, if we try to measure the resistance between these 2 terminals, what should we get? We should get the whole resistance value here, right? Which is the maximum resistance of a potentiometer. So in real life, on top of each potentiometer, a rating is labeled. For example, a potentiometer can be 5 kilo ohm, 10 kilo ohm, 100 kilo ohm, etc. So that rating means that this is the maximum resistance of the meter, okay, which is situated between terminal 1 and terminal 2. So for this particular potentiometer, if we measure the resistance, we will get 5 kilo ohm. Is it clear? Now let's come to the middle terminal, wiper. What does it do? As we know, the wiper of car or any wiper means which can rotate or which we can swap, right? So this is something like this, a tick which we can move to various positions. Okay, so say for example, the wiper is set at this point. Now, if we measure the resistance among these two terminals, terminal 1 and wiper, what we will get? We will get the resistance value of this portion. Just for example, this portion contains 1 kilo ohm resistor. At the same time, if we measure the resistance between the other two terminals, what will be the value? Can anyone tell me? Sorry,
4K sir.
exactly 4K. So I hope you have understood the basic idea. The wiper, what it does, it actually divides a long resistor into two portions. If the wiper is exactly in the middle position, both of the resistor on left side and right side will be 2.5 kilo ohm. If the wiper is at leftmost position, what will happen? This will be 0 and this will be 5K. If it is at the rightmost position, this will be 5K and this will be 0. Anything between that, the total 5 kilo ohm resistor would be divided among terminal 1 and terminal 2. Everyone got the idea?
Yes sir.
Okay. So for our purpose, we need to use the wiper and any one of the terminal 1 and terminal 2. We do not need to use both of terminal 1 or terminal 2. Okay. So first, let me show you how we can change the potentiometer resistance. Oh, okay, something I forgot that. Look, that there is no display or there is no reading on the potentiometer. So how can we measure what is the resistance among these two terminal or the right two terminal? We need some sort of meter to measure the resistance, right? Is it clear? To measure a resistance, what we use is called ohm meter. Fortunately, in Tinkercad, the ohm meter is already inside the multimeter. So we can take another multimeter and change its mode to resistance. Okay. If we change the mode to resistance, we will be able to use it as a ohm meter. Now let me connect the two terminals with the terminal 1 and wiper. We are not going to use terminal 2. Is it clear? We must need the wiper and we can take either terminal 1 or 2. So I'm going to take terminal 1 and wiper. Okay, another point to note that there is no, what should I say? There is no polarity or no plus minus in ohm meter or in potentiometer. So you can connect any of the terminal in wiper and another one in terminal 1. There should be no problem. Okay, let me simulate the circuit. Now, please observe that, sorry. I can put my mouse here and drag this knob. As I rotate this knob clockwise, the potentiometer value is increasing and the maximum value it is showing is 250 kilo ohm. The minimum should be 0 ohm. Okay. So if I set it somewhere between this, say it is 90 kilo. Everyone got the idea? Okay. Now for our case, we do not need like 100 kilo ohm resistance, right? We just discussed a bit earlier. কিছু বললেন?
স্যার আমার কথা কি শোনা যাচ্ছে?
হ্যাঁ বলেন তো কি বলতেছেন? বলেন, শুনতে পাচ্ছি, বলেন।
স্যার হচ্ছে মানে আজকে কি স্যার অ্যাটেন্ডেন্স নেওয়া হবে স্যার? মানে মানে
না না,
স্যার
ওই যে
ঠিকমতো
আপনাদের
কথা শোনা
গত
যাচ্ছে না
সপ্তাহ
স্যার,
আগে
মানে
আগের সপ্তাহ পর্যন্ত টাইম থাকবে, ওর
স্যার
মধ্যে
ভার্সিটিতে
সাবমিশন
আছি
করলে
স্যার।
অ্যাটেন্ডেন্স, সমস্যা নেই, আপনি ক্লাস না করলেও চলবে। ঠিক আছে।
আচ্ছা স্যার।
স্যার
ইয়েস,
মাঝখানে কথা কেটে গেছে, ওয়াইপারটা মানে কিভাবে মুভ করছেন এখানে?
আচ্ছা
আর
আচ্ছা,
মাঝখানে
আগে
যে-
সার্কিটটা সিমুলেট দিয়ে নিবেন, তারপরে ওয়াইপারের উপর মাউসটা চেপে ধরে রাখবেন, মানে লেফট বাটনটা চেপে ধরে রেখে ড্র্যাগ করবেন, তাহলে মুভ হবে। ওকে, okay students, now for our task we do not need a lot of resistance here. Maybe what can be our maximum value today? Maybe 3 kilo ohm, 4 kilo ohm, that should be enough. So we are going to change the maximum value of this potentiometer. Stop the simulation, click on the potentiometer, and you should be able to see this dialog box. This value written here is the maximum value of your potentiometer. We do not need it 5 kilo ohm, sorry, we do not need it 250 kilo ohm. You can set it to 4K or maybe 5K. That should be enough. Everyone understood what I just said?
স্যার আরেকবার রিপিট করবেন একটু?
আমাদের যেহেতু আরথেভেনিনের মানটা অনেক ছোট, লাইক 1 কিলো ওহমের আশেপাশে, তো আমাদের আরএল এর ভ্যালুগুলো কিরকম হবে? 1 কিলো ওহমের চেয়ে ছোট কিছু ভ্যালু আর 1 কিলো ওহমের চেয়ে বড়, মানে 3 বা 4 কিলো ওহমের কিছু ভ্যালু। সেই জন্য পটের ম্যাক্সিমাম ভ্যালুটা সেট করে নিচ্ছি 4 অথবা 5 কিলো ওহমে। পটের উপর একটা লেফট ক্লিক করেন, এই ম্যাক্সিমাম ভ্যালুটা সেট করে দেন 4 অথবা 5 কিলো। কারো কারো হয়তো আরেকটু বেশি লাগতে পারে, 6 বা 7 কিলো লাগতে পারে, এর বেশি মেবি লাগবে না। Okay, next. Next, what we need to do is connect the potentiometer in our main circuit. Okay. So here we need to tweak some connections. Please observe that the end terminal of Thevenin is connected with terminal 1 of our load resistor or pot. And what should be the connection with the negative terminal of source? Where should we connect this one? With which terminal of potentiometer we need to connect the source? Someone?
ওয়াইপার।
Exactly, this one, the wiper. So this wire is serving no purpose for now. I am going to delete it and connect a wire from wiper to the negative terminal. Okay, just let me move this to avoid any overlap. That's it. Has everyone understood the connection? First terminal is connected with Thevenin. Wiper terminal is connected with negative source. The terminal 2 is not connected with anything. Okay.
স্যার এখানে কি ওয়্যার ওভারল্যাপের জন্য কোনো ভ্যালু চেঞ্জ করে?
ওয়্যার ওভারল্যাপ হলে না, কোনো সমস্যা হয় না, জাস্ট দেখতে একটু যাতে কনফিউশন না লাগে এই জন্য ওয়্যারটা চেঞ্জ করে নিই।
স্যার
Okay. So let's complete our first observation. My Thevenin, sorry, my Thevenin was 0.83 kilo ohm. So I will try to take the RL around say 100 ohm, 0.1 kilo ohm. But do not write it first here, because in potentiometer you are not able to select any value you want. If you move the knob slightly, you will observe a sudden change of resistance. So let me bring it again here to measure the resistance. Start the simulation and let's see what is the minimum value I can set here. Oh, that's great. Yes, I am able to set it to 101 ohm. Maybe not 100 ohm. Yep. Please observe that whenever I am trying to set it at a minimum value, it is automatically set at 101 ohm. So maybe some of you will see 130, 160, doesn't matter. Just any low value would serve our purpose. So I am going to write this value here, 0.101 kilo ohm. Now the measurement is done. Please make sure after a measurement you do not touch this knob, because if this knob is moved, your register value will change. So now stop the simulation and put the potentiometer in the original circuit. Then you can start the simulation again and you should be able to see the, what should we call it, the voltage across load, the VL. In my case it is 575 millivolt, so I am going to write it in volt unit, 0.575. That's it. Has everyone done
আমার
this?
তো অনেক
first of
কম
all?
আসছে 5 পয়েন্ট কত জানি
একটু জোরে।
আমার অনেক কম আসছে 4.35 আসছে
4.35 কি মিলিভোল্ট?
জি স্যার
আচ্ছা, আপনার আরএল টা কত নিছেন? মানে পটেনশিওমিটারটা কততে সেট করা এখন?
এক মিনিট স্যার
পটেনশিওমিটারটা এই যে এখানে মেজার করে নিতে বলছি, যে কততে মেজার করে নিছেন? এটা সম্ভবত অনেক বেশি কিছু সেট হয়ে আছে, ওইটা একটু কমায় নেন তাহলে ঠিক হয়ে যাওয়ার কথা। Okay, so everyone, please be attentive for a minute. I am going to show you how to fill up all the remaining columns. You do not need Tinkercad. You just need to write down the formulas. Okay, for your convenience, I have already written the current formula here. It should automatically be calculated in your data sheet. Now the remaining formulas I am going to write now, and please observe carefully. Look, every formula is already written in this cell. Input power. What is the input power? The power that is supplied by this source, right? So how can we measure it? We know the power formula is voltage into current. So for this power supply, the voltage is Thevenin and the current is same as IL, because this is a series circuit. So there is only one single current flowing through the entire circuit. So we can use this formula for calculating input power. Now let me write the Excel function. First put an equal sign. Then what was my Thevenin? 5.33. Okay, so I'm just manually writing 5.33 into IL. Please observe that IL will be a variable for each of your observation. So where we can find the IL? In this cell. So I'm clicking on the cell, press and enter, and this is my input power, 30.3 milliwatt. Similarly, output power, load voltage into load current. So I'm going to write the function here, equal, where is my load voltage? This one, into Where is the load current? This one. So that is the output power.
আচ্ছা আদনান ভাই আমি একটু ইন্টারাপ্ট করছি
Sure.
আমাকে না একটা মানে 251 এর একটা এক্সট্রা ক্লাস এখনই নিতে হবে আমাকে
আচ্ছা, আচ্ছা,
মানে
ও।
মাত্রই জানানো হলো আর কি তো
হ্যাঁ।
আমি কি লিভ নিতে পারি
হ্যাঁ, হ্যাঁ,
মানে
sure, আপনার সমস্যা নেই। এই যে আমি
আচ্ছা।
জাস্ট ওদেরকে এইটাই দেখা দিয়ে শেষ করে দিব।
আচ্ছা থ্যাংক ইউ
আপনি তাহলে লিভ নিতে পারেন। ওকে, ঠিক আছে।
আচ্ছা ওকে
Okay, next, the loss. Loss formula is very simple. Input power minus output power. So how can we write it? Equal sign. Click on the input power cell minus click on the output power cell. That's it. That is the loss. Next, efficiency. This formula is written in percentage term. Output power divided by input power into 100%. Okay, so let me write it. Where is the output power? Here, divide by input power into 100. That is the efficiency in percentage. And finally, a new term. Maybe you have not heard of this before. Voltage regulation. Have you heard this in your theory class? Voltage regulation, VR. Okay, so for today's lab, I think I can, I do not need to explain the voltage regulation term because hopefully you will cover it in your theory class. For today, we just need to know the formula, how to calculate voltage regulation. The formula is very simple. R Thevenin divided by RL. So I'm going to write down the formula equal, what was my R Thevenin? 0.8315. Okay, 0.8315 divided by RL will be different for each observation. So I'm clicking on this cell. R Thevenin by RL into 100%. So that is the value of voltage regulation in percentage. Okay, that's the observation one. Now, if anyone has any confusion, you can ask.
স্যার এফিশিয়েন্সিতে আমার ভ্যালুটা খুবই লো আসছে।
হ্যাঁ, প্রথম দিকে লো আসবে। কত আসছে? 1 2 3 এরকম?
না 0.145
মানে 100 দিয়ে গুণ করার পরে 0.145?
জি
তাই 100 দিয়ে গুণ করার পরেও এত ছোট? আচ্ছা, আপনার
আচ্ছা।
ইনপুট পাওয়ার কত আর আউটপুট পাওয়ার কত?
40 and 5
40 মিলিওয়াট আর একটা হচ্ছে 5 মিলিওয়াট, তাই তো?
জি জি
তাহলে আপনি মুখে মুখে ক্যালকুলেশন করেন 5/40, এটাকে 100 দিয়ে গুণ করলে কত হয়? 5/40 মানে হচ্ছে 1/8, তাই তো?
8 it should be
1/8 মানে হচ্ছে 0.125, তার মানে 12.5% হওয়ার কথা। তাহলে ফাংশনটা একটু ভুল লিখছেন, আরেকবার দেখেন।
না মানে ঠিক আছে, আমার ওই মানে এরকমই আর কি, মানে কাছাকাছি, মানে আমার তো এক্স্যাক্টলি 40.17 সামথিং দেন 5.82। আচ্ছা আচ্ছা, না আপনার যেমন 10% বা 10 আসছে না, মানে ওরকম বড় ভ্যালু আসে না, এই কারণে আর কি আস্ক করলাম।
না, আপনি কি পার্সেন্টেজে নিছেন তো, মানে 100 দিয়ে গুণ করছেন?
জি জি
100 দিয়ে গুণ করলে তো আপনারটা 10 এর কাছাকাছি আসার কথা।
আচ্ছা, আমি ক্যালকুলেশনটা আবার করি তাহলে।
আবার দেখেন, পি আউট ডিভাইড বাই পি ইন, তারপরে জাস্ট ইনটু 100। Okay, anyone else, any confusion about any formula? Okay, so if everyone is done with the first observation, the rest is your job to complete. What we will do, I am just showing you observation number 2 so that you understand the repetitive process. Every time you need to adjust the potentiometer first. Remove the potentiometer from original circuit, place it over here, adjust it to a new value. Say my second value is 200 ohms. After adjusting the value, again put it here and then take the voltage reading. So this is my second observation. RL 201 ohm or 0.201 kilo ohm, and for that load the VL is 1.04 volt. 1.04 volt. Okay. Now, if you have written all the formulas correctly, you do not need to write those each time. What you can do is put your cursor on the bottom right corner of this cell and drag it down up to here. All the formulas will automatically be copied and calculated. See, my observation number 2, this row is automatically done. So that's it. Pretty easy, right? So you need to complete this observation, and this is actually your home task. Okay. So last task for today. Everyone, please be attentive. You do not need to complete this graph right now. I am just putting some dummy values here to show you, to demonstrate you how you will draw the graphs in Google Sheet. Okay. So let me just put some dummy values here. Say 0.51, 1.52.
আমার না ওই লোড ভোল্টেজটা অনেক কম আসতেছে, আমি ট্রাই করলাম অনেকবার।
লোড ভোল্টেজটা কত আসছে? একটু জোরে।
4.35 আসতেছে স্যার।
মিলিভোল্ট?
জি স্যার।
আচ্ছা, তাহলে আপনারটা মনে হচ্ছে একটু দেখতে হবে। দেখি একটু স্ক্রিন শেয়ার দেন। মিলিভোল্ট দেখাচ্ছে, তাই তো? আচ্ছা, একটু Thevenin এর উপর ক্লিক করেন স্টপ সিমুলেশন দিয়ে। Thevenin যেটা মানে ফিক্সড রেজিস্টরটা, মানে ওটা ভ্যালুটা জাস্ট দেখতে চাচ্ছি। এটা আছে 0.58 কিলো ওহম। ওকে, ঠিক আছে। সোর্সের উপর একটা ক্লিক করেন। সোর্সটা আছে হচ্ছে ভোল্টেজ 5.02 ভোল্ট। এটা আপনার Thevenin ছিল, তাই তো? আচ্ছা, ঠিক আছে।
মেবি স্যার এই যে এইটা
হ্যাঁ, না, এটা তো Thevenin, আর সোর্সের ভ্যালুটা হবে হচ্ছে Thevenin, তাই দিছেন না নাকি? এটা হচ্ছে Thevenin 0.58 কিলো ওহম, এটা একটা রেজিস্ট্যান্স। আর সোর্সের মানে পাওয়ার সাপ্লাইয়ের ভোল্টেজটা হচ্ছে আপনার Thevenin। সেটা ঠিকঠাক মতো দিছেন তো?
না স্যার, এটা ভুল হয়েছে, বুঝতে পারছি স্যার। এবার
আচ্ছা, একটু ঠিক করেন এখনই। আপনার Thevenin কত ছিল? ডাটা শিটে যান।
Thevenin হচ্ছে 5.02 ছিল।
হ্যাঁ, তা ওইটাই তো দিছেন না সোর্সে, পাওয়ার সাপ্লাই 5.02 তো দিছেন, ঠিকই তো আছে। হ্যাঁ,
হ্যাঁ এটা ঠিক ছিল, কিন্তু এই যে 5.57 ছিল।
এটা আপনার কত আসছে সেটা ঠিক করেন।
5.5।
আপনি তো 0 পয়েন্ট দিচ্ছেন আর মুখে বলতেছেন 5 পয়েন্ট, বুঝলাম না।
না সরি স্যার, 0.5।
0.5 কিলো ওহম, এটাই আপনার Thevenin ছিল, তাই তো?
জি স্যার।
ওকে, ঠিক আছে, থাকুক। আচ্ছা, এবার ওই যে পটটাকে খুলে নিচের মাল্টিমিটারের এখানে বসান দেখি। হ্যাঁ, দেখি পটের ভ্যালুটা কত আছে। সিমুলেশন দেন। এই যে পটের ভ্যালুটা তো একদম 0 হয়ে আছে। এই পটের নবটা এখন একটু ঘুরান, সিমুলেশন থাকা অবস্থাতেই। হ্যাঁ, স্টার্ট সিমুলেশন দেন। হ্যাঁ, এখন পটের ভ্যালুটা সামান্য ঘুরান। এই যে দেখছেন আপনারটা তো কিলো ওহমে সেট হয়ে যাচ্ছে, অনেক বড় ভ্যালু দেয় আপনার পটে। সিমুলেশন স্টপ করেন, বললাম তো এটা একটু আগে। হ্যাঁ, পটের উপর একটা লেফট ক্লিক করেন, পটের ম্যাক্সিমামটা সেট করেন, জাস্ট যে কোনো জায়গায় লেফট ক্লিক, একটা ডায়লগ বক্স আসবে, এটা লেফট ক্লিক করেন।
আস্তে আস্তে
পটের কর্নারের দিকে, মানে ওই যে কালো যে কোনো জায়গায়। হ্যাঁ ঠিক আছে, ওকে। ওই যে রেজিস্ট্যান্সটা কমান, এটা 200 কিলো ওহম কেন দিছেন বললাম না, যেটা কারো হয়তো 5-6 কিলো ওহম লাগবে, তো আপনার আর থেভেনিন কত 0.5, তাইলে আপনার তো 4 কিলো ওহমই মনে হয় হয়ে যাবে, 4 কিলো ওহম দিতে পারেন। হ্যাঁ ব্যাস, আর কিছু লেখা লাগবে না। ওকে, এবার সিমুলেশন স্টার্ট করেন। এবার পটের ভ্যালুটা ওই যে ছোট একটা ভ্যালুতে সেট করেন, যেটা আপনি প্রথম অবজারভেশনে নিতে চান। যেমন আমি প্রথম অবজারভেশনে নিলাম কত, 100 ওহম। কমান, আরো কমান, 900 ওহমে আছে। এই তো, হ্যাঁ ঘুরান, একটু ঘুরান। ওকে 240, ঠিক আছে, এর কমে মনে হয় আর হচ্ছে না। না, এই যে এটা, হ্যাঁ ছেড়ে দেন। এই তো ব্যাস, এই ভ্যালুটাই আপনি নিতে পারেন, 80.5 ওহম। এবার এটাকে মেইন সার্কিটে বসান। এখন আপনার ঠিক মতো আসছে। ওকে, তো এই কাজটাই প্রতিবারই পট সরাই এখানে নিয়ে আসবেন, পটে নতুন একটা ভ্যালু সেট করবেন, তারপর আবার সেটা মেইন সার্কিটে নিয়ে গিয়ে রিডিং নেবেন। আচ্ছা, স্টপ করে দেন, আমি স্ক্রিনটা শেয়ার দেই। Okay, so students, now I am going to show you how to plot the graphs in this Google Sheet. So for that purpose, I am just putting some random values in RL and VL. Okay, so you will complete your task in home. Just now observe the three, 3.5. Okay, ঠিক আছে। Okay, so these are some random values. Now what we need to plot here, the required plots are mentioned in your lab sheet. You have to plot these 6 graphs. Please observe that every graph is plotted with respect to load register, because this is the only variable, the only quantity that we are varying in this circuit, right? So every time we vary load register and observe what is the effect on a particular quantity. So for example, let's say that I want to plot the output power like this. X-axis will be RL and Y-axis would be P out. Okay, so I am going to select the column of RL like this, and then go to this option, insert chart. Now the chart can be initially of different type. Please observe carefully what we need to modify here. First of all, we need a line chart or line graph. So you can select this one or the smooth line. Both will serve the purpose. Okay, x-axis. So in our x-axis, we want the load register values, right? So observe here. Sorry. My load register values are from C18 number cell to C26 number cell. So I am going to set this range in x-axis. Okay, go to the edit chart option, add x-axis and this should be automatically shown in suggestion. If it is not shown, what you can do, click on this select data range option and manually write C18 to C26. That's it. Okay, so this is our x-axis. Now what should we plot in y-axis? I want to plot the output power in y-axis. Okay, so where is my output power? Look, my output power is from G18 number cell all the way up to G26 number cell. So I am going to add it. Add series. Series means the y-axis graph. Okay, so in add series option, I cannot see that in the suggestion, so I'm going to select data range G18 to G26. That's it. Okay, the C18 series are already plotted, we do not need it, so I'm going to remove it. So this is your output power plot. In addition to this, let me show you the output current. The output current is here from E18 to E26. Again, I am going to edit chart option, add series, select data range E18 to E26. Okay. So now you can see two graphs. Yes, please.
Sir,
বলেন।
হ্যালো,
হ্যাঁ বলেন, শুনতে পাচ্ছি।
বাই এক্সিসটা প্লট করার পর আপনি কি করেছিলেন যে ব্লু লাইনটা এসেছে?
কোনটার পরে?
বাই এক্সিসে ও
আচ্ছা,
আউটপুট পাওয়ারটা দাও।
এই যে অ্যাড সিরিজ অপশনে গিয়ে ওয়াই অ্যাক্সিসে যেটা প্লট করতে চাচ্ছি সেটা রেঞ্জটা লিখে দিছিলাম, লিখে ওকে দিলেই চলে আসবে প্লটটা। আসতেছে নাকি আসে না?
ওকে স্যার।
So you need to plot the 6 quantities, right? Now when I observe or when I am going to check your data sheet, how can I understand which one is denoted by which color? So you must mention it. How can you mention it? For example, my blue graph is output power, right? So click here on the blue line, double click, sorry, not single click, and there should be a text label option. So I'm going to write P out. See, the blue graph is now labeled as P out. Similarly, I am going to put IL for the red graph. So this is IL. Okay. And I think something is still wrong. Look, the y-axis is shown as RL, but this shouldn't be. Our x-axis is RL, right? So we need to correct the axis titles. How can we do that? Axis title. Look, there is a setup option and a customize option. Go to customize, chart and axis title. From chart title, select the horizontal axis title. And in horizontal axis title, write RL. Now it is showing RL. And I think I should delete it. The y-axis is not RL. How can I do it? Go to vertical axis title and just delete the title axis. Additionally, you can also add a chart title. Chart title is this one here. So what is this? This is our, like, what can we call this chart? Observation of variable load, like something like that. Okay, you can change the chart title as you wish.
স্যার,
Yes.
আমরা কি একটার মধ্যে 6টাই প্লট করব নাকি 6টা আলাদা আলাদা?
I'm going to tell you that. See, if you plot all the graphs in one chart, what can happen? Just let me show you an example of adding voltage regulation. My voltage regulation is J18 to J26. Okay, let me add this series here, J18 to J26. Now, as you can see, the voltage regulation values are pretty higher compared to others. So when this graph is plotted, all the other graphs are like almost vanished. I need to zoom in a lot to observe those shapes. So when you are plotting, please make sure that this case doesn't happen. You do not need to plot all the 6 graphs in single chart. What you can do is at least plot the VR in a different graph, because the VR value is going to be pretty different than others. So plot VR in a different chart, and then observe that if you plot the 5 graphs, the rest of the 5 graphs in a single chart, is it comparable, or is the shapes observable? I mean, can we understand the shape of the graphs? For example, I told you earlier that the output power graph should be like this. Now, if there is some large values for which the output is going to show like this, this is not going to be visually pleasant. So please make sure to plot the graphs accordingly. Okay, সবাই বুঝতে পারছি? সবগুলো একই গ্রাফে প্লট করাটা জরুরি না। যেভাবে প্লট করলে আপনার গ্রাফগুলোর শেপ সুন্দর মতো বোঝা যাচ্ছে, সেই গ্রাফগুলোকে একসাথে প্লট দিতে পারে। Maybe the VL, IL, and the output power. I think you can put these 3 graphs in a single chart. I'm not sure about the others. Please observe what happens to other values and then plot those. Okay. So that's the end of our today's lab. Now, if anyone has any question, you can ask, or we can end this class.
স্যার ডেডলাইন কবে?
এক সপ্তাহ, মানে আপনাদের আগামী সোমবারের আগের দিন পর্যন্ত। The deadline is Sunday 12 or so, Sunday 11:59 p.m. next Sunday.
স্যার লোডের ওই যে ওইখানে আপনি কি যেন একটা বলেছিলেন যে আমাদের ওই যে ভ্যালুর রেঞ্জটা কি রকম হবে?
আচ্ছা, ভ্যালু রেঞ্জটা হবে হচ্ছে আপনার Thevenin এর চেয়ে ছোট কিছু বড় কিছু। মানে ধরেন আমার Thevenin এসেছিল 0.8 কিলো, তাহলে আমি 0.1 কিলো থেকে শুরু করে এপাশে হয়তো 3 বা 4 কিলো পর্যন্ত যেতে পারি, মোটামুটি এরকম একটা রেঞ্জ।
Thevenin এর এক্সাক্ট ভ্যালুটা তো আমরা পাবো না, মানে ওইটা তো
একদম হুবহু ওইটা তো মনে হয় পটে সেট করতে পারবেন না, ওইটার কাছাকাছি একটা ভ্যালু নেবেন যতটুকু নিয়ে পারেন।
আচ্ছা আচ্ছা, ঠিক আছে, থ্যাংক ইউ স্যার।
Anyone else? Any question?
এইখানে তো এই যে জাস্ট এই দুইটা পার্টি, এটা এই এক্সপেরিমেন্ট 6,
মানে তাহলে এই দুইটা সার্কিট টিঙ্কারক্যাডে থাকবে আর এই ডাটা শিটটা সাবমিট করতে হবে, এটুকুই আপনাদের কাজ।
থ্যাংক ইউ স্যার।
Okay, so last point, that please make sure both of your circuits are included in the class activity so that we can count the attendance from here, and also make sure that you properly fill up the data sheet and submit it within the deadline. The deadline is next Sunday 11:59 p.m.
স্যার
Yes, please.
স্যার এই চার্টগুলো করে কি এটা কি আমরা ডাটা শিটটাতে অ্যাটাচ করে দিব?
Yes, yes, yes. এই ডাটা শিটের মধ্যেই এই গ্রাফগুলো থাকবে, জাস্ট এই একটা ফাইলই সাবমিট করবেন, মানে আলাদা ডাটা মানে আলাদা গ্রাফের জন্য কোনো জেপিজি ফাইল বা কিছু সাবমিট করতে হবে না।
আচ্ছা স্যার, আমার প্রিভিয়াস ল্যাব গুলো সম্পর্কে আর কি একটুখানি কোশ্চেন ছিল।
ঠিক আছে, তাহলে আমি এটা একটু রেকর্ডিংটা এন্ড করে নেই। So that's it for today. Let me stop the recording.